Hello, this is the first pre-recorded lecture for Math 155A at UCSD, fall of 2020, during the time of COVID-19. This is a course in mathematical computer graphics. The course will cover both mathematical aspects of graphics, but also programming and OpenGL. There's a number of resources available online. The video sequence that I'm giving right now, this is the first one, is of course part of it. It follows the textbook rather carefully, and the textbook is online in PDF format at the URL shown here, math.ucsd.edu/mathcg2. This is a full PDF version of a revised version of the textbook. It's still under revision, so there'll still be changes going in. I very much appreciate getting corrections from those of you in the course this fall. And you do not need to purchase the textbook. This is the second edition. It's using the modern OpenGL as compared to the older OpenGL version. And so you should use the online version of it and do not purchase the first edition. The same URL also has sample C++ and OpenGL programs, and we will, over the course of the quarter, be learning how to write programs in OpenGL using C++ and building our way up to fairly sophisticated code. As I said, the course is a blend of mathematics and programming. The lectures will cover primarily the mathematics part, but we'll also use the OpenGL part throughout the course. And OpenGL is a programming API. It's an API for particular C++ programs to use to do graphics in conjunction with a GPU, graphics processing unit. A graphics processing unit is an add-on to a computer. It's an additional computing resource. It works with the CPU, the central processing unit, but the GPU is basically like a small parallel computer. It has maybe thousands of cores on it. A GPU may have thousands of so-called cores, small computer cores, and they run small programs called shaders. The shaders are written in a language called GLSL, and we'll see how to write simple versions of that during the course. OpenGL is widely available on Windows and Linux. You probably have to do some special installation to get it to work, but it's not very much extra work. It runs also on most Macintoshes, but Apple is in the process of phasing out support for OpenGL, so the most recently purchased Macintoshes may not be able to use OpenGL. It depends on the exact details of what you have. But it's a widely used program, OpenGL is a widely used API, and it works, the principles are similar to other things such as DirectX, which Windows uses. Apple uses Metal now. There's a modern Vulkan as a successor to OpenGL. All of these things use similar principles to OpenGL. So by using OpenGL, it's a representative program, a representative method of doing graphics code, and it's the same principles used in all of the methods for graphics nowadays. So the most commonly way to use OpenGL is you have a CPU and a GPU. So the CPU is the central processing unit on your computer. The GPU is the graphics processing unit. Which is usually, when you have a separate GPU, is a separate chip that does the GPU work. It can also be simulated by other methods, but the CPU we would be coding in a C++ program, and it's going to render a 3D scene or other scene usually as triangles. So it's going to basically draw triangles or lines or points, but triangles is the most common. And we draw these triangles, so we're drawing some shape, we approximate it by triangles, and we draw the triangles. To specify triangles, we specify vertices. The vertices, these are points usually in R3, so we specify them as 3 tuples. And we also specify how they transform to the 2D image, because in the end we want to display the image on a screen of some type or a photograph or something, and that's a flat image. So we're specifying things in 3 space, it gets mapped down to a position in 2 space, and this typically uses 4x4 matrices, for reasons we'll learn about in a few weeks, and it also specifies other vertex attributes, other properties of the vertex, of the vertices. And these might be such as maybe the color or texture coordinates, or really any other property you wish to specify about vertices. So this is all done on the CPU side, and when we specify this information, it gets loaded into array, and then it all gets shipped to the GPU, along with drawing commands, and then it then gives also drawing commands to the GPU. And the GPU has typically at least 2 kinds of shaders. It has Vertex Shaders. And a Vertex Shader, it's a small program. It's called a shader, but it's really a program. A program that is run on every vertex. So in other words, we're specifying triangles, say, by giving the corners, the vertices of the triangles, and then the GPU runs a program on each vertex, possibly changing attributes of the vertex. And then it has also what's known as a fragment shader. Maybe a better name for a fragment shader would have been a pixel shader, but think of fragment as meaning the same thing as pixel. A pixel shader, or fragment shader, is a program that runs on each pixel in each triangle, or each line, as it were. And so in other words, we can actually write a little program that, sometimes not so little, that runs on every single pixel in the image as we draw it. We draw a triangle, it gets mapped out from the CPU to the GPU maps it to pixels in the screen, the vertex shader is run first for each of the vertices in the triangle, and then the fragment shader is run on each pixel covered by the triangle. And the point here of the fragment shader is, if we're drawing a triangle, we specify 3 vertices, and then we usually want to draw, so if we're drawing a 3-dimensional solid object, we usually want it to be filled in. And so the job here of the shaders is we want to fill in or shade the triangle. So although we've specified the triangle as 3 vertices, we want it to look like a solid triangle in the final image. So that's why the programs are called shaders, because they take care of this process of shading the triangle. But they are very general purpose programs. They could do whatever you want. Okay, so as I said, this is the introductory lecture. It's very short. I'm going to stop here. The next lecture will talk about the details of how a C++ program would describe points and lines and triangles that get shipped out to the GPU. Thank you.